Alright, hello everybody. We're in section 3.3, Systems of Linear Inequalities. So far, you have graphed a system and found out if they crossed or not, and that was one way to solve it. The second way to solve a system was by substitution, and the third way to solve it was by elimination. So that's three ways to solve a system of equations, which is just more than one equation with the same variables going on. So today, we're going to look at a system of linear inequalities. So it's kind of like two equations, but they're going to have the less than signs, the greater than signs, and we're going to have some shading involved. And so our solution is going to look like a graph. So we'll get started. Here we go. So as you see here, our goal basically is to get each equation that we have into y equals mx plus b form. If we have that, then you're going to be in a lot better shape to graph them manually. However, I will show you how to do this on the calculator, but it's good to know how to do this by hand, because if you don't have access to the calculator at home or practicing these things on your own, then you need to know how to do these by hand as well. So some of our age-old type of tricks to graphing inequalities show up as well in this. So if we're going to use y-intercept and slope. So that's the y-intercept is the b value, and slope is the rate of change, the m value. But we also use our less than and greater than signs to tell us kind of about the line. In this case, you see that less than and greater than do not have equals applied to them, so they are a dashed line. And then when you have the equal sign applied, those are solid lines. Make sure you keep that exactly correct, because you don't want to mess that up. Solid means you can be equal to it, and dashed means it has to be inside it or outside it, whichever way you're looking on your graph. So, for example, there's another set of details that we've got to know, and you saw all this back in chapter 2, section 8, I believe, when we graphed absolute value inequalities on our graph paper. But here you see when it's graphed above the line, you have greater than or greater than or equal to. So when you are shading, in a sense, you're going to shade above the line when you have the y first and then your symbol. Y first, then your symbol. So if it's greater than, think above shading. And when it's less than, think below for the shading. Pretty simple overall. Be careful when you flip this around if it's your stuff and then less than y. Then you need to read it from the y's perspective. The y perspective will help you understand if it's above or below for greater or lesser. So here we go. For example, we have two equations. We're going to label them A and B, and we have 3x. We have 3x plus 4y greater than -4, and we have x plus 2y is less than 2. So let's address these both. You see in my rough sketching down here, I have tried to get them in the slope-intercept form, which means basically to solve them for y. So I took the first equation, or inequality, and I subtracted 3x to the right side. So minus 3x goes away right there, and -4 still shows up, but it has a -3x as well with it. The sign is still the same, so 4y is greater than that. The last step, I've got to divide everything by 4. Well, that leaves me just a y is greater than -3 divided by 4, x, and -4 divided by 4 is -1. So there's my new equation, m of -3/4 and b of -1. Move on to your blue. So I want to keep my y in place, so I subtracted my x to the right side, so -x plus the 2, and then I have to divide by 2. So that lends me a y is less than, and -1 divided by 2 is just -1 over 2, x, and 2 divided by 2 is plus 1. I never had to switch my symbol on either case because I never divided by a negative value. Keep that in mind. Now, before we put this on a graph, just go over a few details. You have greater than and you have less than. So greater than means we're going to have a dotted line or dashed line, And greater than also means that we're going to shade on top of that line. Just that line in particular. Those are the details for it. For line B, we are less than. So that means we are still dotted or dashed. It's not equal to. And then we're going to shade below that line. So keep that in mind when we get down to our graph paper. Alright? Okay, everybody. Here we go. We are going to graph our first equation. You could use x and y intercepts, or you could use what I used, and that's solving for y and using your b and your m to generate your points. So, if I wanted to actually draw some points on here, at -1, there's a point. So I'll put my blue dot right there. So at -1, I can go down 3 and forward 4. So if I go down 1, 2, 3, and 1, 2, 3, 4, I should have a point about right there where you see my blue dot showing up again. Now I could also go up 1, 2, 3 and backwards 1, 2, 3, 4 and be somewhere right here. So you see how I have the dashed line and it goes through here. Now we also said that it was going to be shaded above since it's greater than. So that's where you see all the red marks, or my blue marks in this case, shaded above. Alright, keep that in mind. Let's go get the blue one and put it on top of this graph. Okay, so what you see on here is the blue graph is less than -1/2 x minus 1. So I think that should be a +1. Let's find out. Yeah, the y-axis should actually be a +1. So let's put a little plus right there. That's the y-intercept. So here we are at +1 on the green dot you see there right there. And my slope is down 1 over 2, so I'm going to go down 1 over 1, 2, and there's that one. I can go down 1 over 2 again, and there's that. I can go back to my original point and go up 1 and back to, there it is. So you see we have our blue dashed line. I'm putting my green line over that so you can identify it. Now the blue is a line that is less than, so I will shade underneath it. So I hope that you see that where they overlap is in this space right here. I'm going to highlight this better on the next slide, but I want you to notice that that little sliver is where all the answers are going to be, since they are both greater than the red one and they are less than the blue. So understand that our overlap region is the actual answer. Alright, keep that in mind. So here you go. You've got the overlap region showing. They are telling you that basically that region is where all of your solutions may lie. So there's not just one solution when you do these inequalities. There are more than one in a lot of cases. And remember, we cannot have an answer that's on the dotted line, the dashed line. That's not allowed because it's not equal to. But we can be everything in between it. And I also want to point out the fact that you guys actually may still even see a POI somewhere in that region. That's fine. We can have POIs. But that's not part of our answer in this case because it's a dashed line. When they're solid lines, when they're both solid lines, then that could be a possible answer, the POI itself. So keep that in mind. You're going to have questions that are like this, but you'll also have some questions that may be a little different from this. But overall, the overall idea is to find the region where they are overlapping and call that your answer space. Okay? If you have any questions, bring them to class. I look forward to helping you out with this. We're getting closer to a test, so this is section 3.3. We've got 2 more down. All right. In any case, I'll see you guys next time in class, and always remember, flip, don't flop. Adios.